Hello, and welcome to another one of my recordings. Through this recording, I'm going to cover some of the concepts in Chapter 10 of your book, where the authors discuss thinking in objects. So essentially, we'll touch upon objects, classes, and also methods, and we'll also talk about some of the topics like it's using, such as using the this reference and so on. So let's go ahead and get started. Essentially, these are the slides that I've given to you in Canvas. So these slides are available. So I'm just going to kind of walk through these slides and kind of touch upon the basic objects. So one of the things that you'll see in Chapter 10 is the concept of immutable or immutable objects and classes. Again, the word immutable essentially means that you cannot change something. Essentially, remember that with what we talked about earlier about objects and classes, is that by convention we want to have a class with all private data fields. Now, if we don't give it a mutator method, or an accessor method, then we won't be able to change the values of those data fields. So the immutability is a little bit more advanced topic also that we'll cover in CIT 230. But so that just so you know that it's usually used when you want to secure code. And again, that's something that we don't touch upon in this class. So I'm just going to go over this. Maybe do a couple of examples here. Here's a public class student, and I kind of want to actually explain some of these concepts through this example. When you see this definition, public class student, of course, private int ID shouldn't be unfamiliar to you. All we're saying is that ID is a field or an attribute of the student class. It is an integer and it is private, meaning that ID can easily be accessed throughout this class. But right here in this in this test class, ID cannot be directly accessible from here. So I couldn't say student.id. I have to use the student.getID to actually get its value. Now, the other thing that you'll see in here, and we'll talk about through the end of this recording, is the concept of creating an aggregation or a composition, where essentially we're creating a variable, in this case birth date, whose type is a class birth date. And this is probably not a good naming convention where the two variables are different only by a case of the first letter. But what this tells you is that just like this one told you that ID is an integer, here we're saying birth date is a variable of type birth date. So for this to work, you must have a class birth date or class name birth date. So if we just move over here, we see that birth date has three attributes: year, month, and day. And of course, you recognize this method. This is a constructor because it has the same name as the class. It accepts three parameters. And all we're doing is we're setting the year, month, and day to the parameters of this um, method. And here's a public void. This is a set year, which is essentially called a mutator method because it's changing the value of a private variable or the value of a member field. So this is all that means. So when you say birth date is birth date, this variable now has access to all of these attributes and all of its methods, in this case set year. Now, public student int SSN year, month, and day. Obviously, you have a constructor named student with four parameters. ID is equal to SSN, simply sets the ID field of the student equal to what you pass it. And then birth date, remember this variable birth date is as a new object with the year, the month, and the day. So if we follow through here then, New birth date is going to be calling a method named birth date and passing it three parameters. Again, year will go into new year, month will be associated with new month, and day, new day, and so on. Get ID simply returns the ID, and birth date returns the birth date. Now notice birth date is an object, so its type can't be like int or double or float or string. It's going to be the class birth date. So now here you'll see a student equals new student. So obviously you're constructing a new object named student. You're passing four parameters. So we're going to go right here. Find a constructor. Remember, this class could have many other constructors. Well, we find a constructor with four parameters. Social Security would be this number. Year is 1970. Month is 5. Day is 3. So ID for student equals to this number. And then birth date equals new birth date. So year is 1970. So 1970 goes here. So year equals 1970. So whose year equals 1970? It will be the birth date associated with the student. Now, birthday date equals a student dot get birth date. Now, obviously, a student has a method named get birth date. So this entire object is returned back. So this variable date now contains the data for all of these attributes. So when I say date.setYear 2010, I just mutated or changed the birth year of this student through another class, that's what this previous slide was all about, is that we're able to actually mutate a class or the value of an object through another class. Again, the information about mutation really corresponds to having security involved in Java programs. And again, CIT 230 is when we touch on that in a lot more detail. Okay, so let's continue on. Oh, by the way, I just had this little diagram. I don't know if it hopefully makes sense. Here's the student class containing two fields or two pigeonholes or two memory locations. ID just holds a integer, and this box, the date, holds a birth date, which contains the year, the month, and the day. Now, you can read through this because I will provide this for you, but essentially we use the dot notation to refer to these items. So when I say student S, S will have an ID and will have a date. The date for that student S, or whatever object name you call, also has access to the year, the month, and the day. So you'll see that we do something like s.id. Of course, this only works if ID was public. We can also say s.date.year. That's how we kind of drill down into these attributes. So keep this in mind as we'll go through a few more examples. So we'll go back to these slides. All right, so quickly going through this. So immutability, again, your book also covers it. The scope of variables is kind of important to know. Essentially, all instance and static variables are scoped or available within the class. And you've seen this already. So if I go to this example here, I have a public class loan. And notice I've got all these attributes. Well, all of these attributes are available in all of the methods within this class. They are not available within this other class or this test class. So that's what we mean by that. Now, the scope of a local variable starts from its declaration and goes to the end of the block. So if I happen to go in here in this loan.java, and if I, for some reason, right here, double monthly interest rate. Well, this monthly interest rate is just a local variable just for this method. It's only good from here to here. And again, notice I have a variable called annual interest rate, I just created this monthly interest rate as a local variable to hold this the value of this intermediate variable. Again, you don't have to have this, but that's as long as you understand that anything defined within a method is only good within this method. So I can't use monthly interest rate in here, or definitely not in here, because it's only defined within the scope of this method. All right. So go back in here. The this reference, the this keyword is kind of misleading at times, and essentially it's a good way to reference an object within its own class. And the other area we use the this reference is when we want to call constructors of the same class. So I think a good example here will show you the use of the this keyword. Now, notice you have public void or void set I int I. Now, from here you see that I is a private member variable. And now, without the keyword this statement is going to read I equals I, which doesn't make sense, and you'll get an error message. Now, one of the things that I believe we talked about when we talked about chapter 8 is this concept of shadowing or hidden data fields, is that you never want to name your parameters the same as your member fields. So had I called this int I xyz or in or any other variable other than that, then I could have just said I equals in or whatever I named this variable. But if you happen to want to do this, even though it's not a good idea to do it, then you have to use the this reference. So we say this.I. So in this case, this refers to the object that calls this. And this I is equal to this parameter. So this is the way where Java can resolve this issue of having the parameter name being the same as your private member field or member field. Okay. The other example you see here, I have a public circle, which is obviously a constructor circle. And circle has two constructors. One accepts a parameter and one doesn't accept a parameter. So from here, all I'm doing is I'm saying this open print 1.0. All I'm doing is I'm calling this circle, which is this object, with the name of the method, circle, that accepts a parameter. So again, if you didn't put this 1.0, of course, if you don't use this, you get an error message because 1.0 doesn't make sense. If you say circle 1.0, it's okay, but it's preferred to use this reference to implicitly call that. Get area, this.radius, math.pi, not really necessary because there is no confusion. There's only one attribute radius, and we're just using it. So you don't have to use the word this, but you can. Another concept that your chapter 10 talks about is the concept of abstraction and encapsulation. And essentially, all we're saying is that the classes that you define, so in a nutshell, this loan.java, this definition where we write code for all of the, essentially all the mutators and all the functionality in here, when you write this code, this is essentially referred to the implementation of the class loan.java. It says exactly what this program, what this class does. Now, in the test loan class, if I want to create a loan like this, when I say loan equals loan, technically, I don't really need to know the implementation. I don't need to know how this loan class works. All I need to know is what kind of constructors it has and what kind of methods it provides for me. So if I'm given what the book talks about a contract, if I'm given the essentially specification for the use of a class, I shouldn't really need to know how the class does it. So if you tell me that there is a method that calculates annual interest rate, you just give me the name, you tell me whether it needs a parameter or not, and then I should be able to use it in my test class. Remember again that this loan.java or this loan class is probably written by some other programmer, and many programmers are going to be using that same class. And you've seen this with all the predefined classes like the math class or the random class or the scanner class. All we need to know is how to use that class. So that's what they're talking about. And the word encapsulation essentially means hiding. And that's what we mean is that we're hiding all the details. So essentially you're talking about the class implementation as a black box that is hidden from the clients, meaning hidden from the users who use it. So just for, again, the two loan and test loan class also provide that, but they're also included as a part of the student um, data that you download from the author's website. So object-oriented thinking, again, we kind of briefly talked about this in chapter 8, and the main thing or the main concept of OOP is having the ability to reuse code. So the idea is that I fully create the definition of a thing, of any object, and then through a class, and then I can create many objects from that class and use its various methods to perform my operations. So the BMI class is another good example. One other example that may be confusing is the concept of composition and aggregation. Essentially, this is what we just talked about at the very beginning when I had the birth date example. In that example, I had a student who has an ID and also has a birth date. So that birth date essentially says that is a composition of having a object as one of our attributes in a class. In this example, we'll see a UML diagram shortly. We're saying a student has a name. So you can think of a student is composed of a name. Now, a student has many addresses, so we call that an aggregation. By the way, in most places, composition and aggregation really are similar concepts, and some authors choose to break them down. But as long as you realize that the student class could contain fields that are composed of other classes or other objects. So let's see a pretty good example here. Here's public class name. What do you think I'm going to define in the name class? Well, that would be the name of a person. So I might have first name, last name, and middle initial. That's it. How about the class address? Well, I could have city, state, and zip code for a given address. So that's what we call these aggregated classes. Now, the aggregating class is a class that essentially uses these classes. So notice public class student contains a name and an address. Now, I could have just said, instead of saying private name, I could have said private string F name or first name, private string last name, private string middle initial. Well, I'll add three attributes to this class. And for the address, I could have the city, state, and zip code definitions also here. So as you might expect, this public class student will have a whole bunch of attributes. And of course, remember for each attribute, you have to have a whole bunch of methods that get and set those attributes. By doing this, I'm creating this aggregation or composition where I'm saving myself a lot of time, or actually a lot of functionality, by creating variables whose type happen to be other classes. By the way, I can still have my regular int or double or string data types, primitive data types. So that's essentially the concept of class aggregation that is good to know. I'm going to go ahead and kind of go over these because some of this stuff, by the way, in your book, you won't be responsible for in an exam, and your homework assignments will not include it. We've tried to assign homework assignments that usually just use the basic concepts that you need to get out of this class. So I'm going to go over these things and kind of go over the concept of designing a class. Follow standard Java programming style and naming convention. Again, remember when you design a class, you want to make sure that all your attributes are private, and you also provide public methods to access those private fields. You also want to provide constructors, so we are able to create objects in flexible manner. So, for instance, a class student may have a constructor that only sets the ID, um, or another constructor that sets the ID and the first name and the last name. So that way I can create objects with different constructors, or essentially with different methods. So provide a constructor and initialize variables to avoid programming errors. It's always good to initialize all your variables. Notice this, as always, place the data declaration before the constructor, which makes sense. It's just for readability purposes again. Using visibility modifiers, again, as far as visibility is concerned, you wanna think about the public and the private. Again, fields are private, methods are public, and constructors, by the way, are by default are always public because that's the only way you can create objects from them. Um, so we could read those. The static modifier, remember that I think we talked about the static in one of the earlier chapters. The word static, if you precede it, have it before a variable or a method, essentially implies that there's only one copy of that variable and method, and that you don't have to create an object in order to use that static item. So something like math.py is a good example because pi is a predefined static global variable in the class math. So you don't have to create an object in order to use it. And there are several other examples where we might want to use that static concept. The book also talks about the concept of wrapper classes. Essentially, you should remember all of these from back in chapter 1 or 2. Remember that Boolean characters, short byte, integer, long, float, or double are referred to as primitive data types, meaning that they're not predefined classes, and they're given to you by the language. So, and the only and the difference, of course, is that instead of a capital integer, we just use int, or instead of capital double, we use the lowercase double. So, lowercase double is a primitive data type double. Capital case double is a class double. Now, the reason that Java gives you these wrapper classes is that many of the predefined Java classes always expect an object. So even if you want to pass the integer 252 to a class, it has to be wrapped or converted into a object before it can be used. So again, that's just the way that Java operates, and so they give you these predefined wrapper classes, and essentially the usage is pretty straightforward. I just want to give you an example in here. For instance, I have double object. So notice right now this variable double object is actually a object. So I could have said double X or whatever, and it's the capital D, and then I say double dot value of 12.4. So this is a convenient way of taking strings and converting them into integers or doubles. So converting strings to numbers And by the way, it's pretty common because usually if we're reading from files or from database tables, well, we read data as strings, and then if we want to manipulate those strings, we're going to need to have to convert it to a double or an integer, and um, that's why we could use these wrapper classes. And of course, the wrapper classes give you some basic methods that you can use. So value of is a pretty good one that creates a new object and initializes to what you pass it. Of course, remember that this doesn't have to be a constant. You could have a string variable like string s, set it equal to 12.4, and then pass this a variable. Which should be obvious by now, is that anytime you use a constant, you can always use a variable in its place. Oh, this is a good example. I'm sure you've seen this. Integer bracket int array equals 2, 4, 3. Pretty short way of what the Java calls boxing. Um, Essentially using primitive data types to put in this int array. Now remember, this int array is not a primitive int array. Its type is a integer wrapper class, or is a class. And that's the same as saying new integer 2, new integer 4, and new integer 3. Of course, if I were you, I would use this method because it's a lot easier to write um, and see how it works. So essentially that's what we mean, is that int array sub 0, we're just dereferencing or unboxing the individual values into that from that array. All right, let's see, big integer and big decimal is covered in your class, not a very big deal. So this is only if you want to grab or use very large numbers. So this number obviously is way bigger than the size of an integer, and it will fail if you assign it to a regular int variable. But if you use the big integer class, then you could use very large values. Okay, let's see. I think that's it. Okay, so just to wrap things up, chapter 10 essentially is an extension of chapter 8. It talks about I think the most important part of chapter 10 is the use of this reference, which allows you to access hidden data, which we said is not a good idea to use anyways, but if you want to use it, you can. And we also talk about object composition or aggregation, where you save yourself a lot of effort by having the ability to create member attributes whose type are objects of other classes. So a good example was a student having a name and an address, or an employee having a name. Of course, the name could consist of first name, last name, and a middle initial, and the address. And of course, they have salaries and they have hire dates. So you could, if you could create a coherent class that defines everything, then you use that. Otherwise, you just use individual variables to define that. So again, your book gives you a couple of examples on how to use this. And again, I believe the homework assignments on this chapter was supposed to be mainly geared towards the concepts that are not much detailed as discussed in some parts of your textbook. Okay, I hope you enjoyed this recording. Have a good day.